So let's discuss about Rankine cycle. Rankine cycle is theoretical cycle on which steam turbine works. So here, for a steam turbine, what happens is to the turbine we are supplying the heated vapor. So the heated vapor will be having some energy. So this heated vapor will undergo expansion in the turbine. While undergoing expansion, obviously the temperature will decrease. So as temperature and pressure decreases, the vapor will be changing to somewhat water vapor mixture form. So during that expansion, that work is converted to that particular heat extractor is converted to work via turbine. So that's what a steam turbine do. So now to the steam turbine, to supply the steam, heated steam, we are having a boiler. So in boiler, what we do is we will be supplying water to the boiler. So the water in the boiler will be supplied with the heat from the external agency, such that this water will change to steam, and that steam will be supplied to turbine. So at boiler, the water will be present at the boiler. So while supplying heating, obviously vapor will be formed there. So now that water and vapor will be at a particular pressure. So if we are taking water from some well, it will be at a different pressure, say 1 atmospheric pressure. But the water in the boiler will be at 5 bar pressure, say so. So in that case, we cannot supply directly water from the well to boiler. So what we do there is we will be using a pump such that the pressure of the water in the well is increased to 5 bar and that is supplied to boiler. So we are using a pump there. Now, anyway, we have represented a closed cycle here. So once vapor comes out of boiler, it will be going to turbine. So after turbine, vapor will be coming out a water vapor mixture. So what we want to do is we want to convert that entire mixture to water, and after that will be supplied to boiler by using a pump. So in order to convert the entire water vapor to water, what we will use a condenser. So by using condenser, we will be cooling that water vapor mixture and we will be getting water alone. Now we can look into the procedure cycle and all. Before going to this figure, this is the Rankine cycle. We will be looking this one. Here what happens is, this is the basic thing what happens while heating water. So suppose the water will be at this point, say 20 degrees Celsius. So on heating, both the temperature and the pressure will be increasing. So from 22, the temperature will be increasing to 100 degrees Celsius if the pressure is 1 atmosphere. So after that, again if we are heating, the temperature will remain constant at 100 degrees Celsius and the entire water will be converted to vapor. So after this is that particular point. After this point, what happens is the vapor, there will be an increase in temperature of vapor. So during this process, during this part, there will be water vapor mixture. During this part, there will be only water, and during this part, there will be vapor only. So we already said that to the turbine, we are supplying steam. That means steam means only vapor is supplied. So either this point or the vapor after this point is supplied to turbine. Now we can come to this figure. So what we do is, suppose say after condenser we are having after condenser we will be only having water. So that is this point 3. This point 3 represents only water because this is water saturation line. So but the water coming out the condenser will not be having the same pressure as that of boiler. So we will use a pump. So pump is using an adiabatic process. So it is an isentropic process. So by using isentropic process, we will be increasing the pressure. That's what shown here. By the process 3-4, an isentropic pressure, that is by using a pump, we are increasing the pressure. So by 3-4, we have increased the pressure. After that, we will be supplying that water to boiler. So now the water have reached 4 after going through pump. So from the state to 4, we are supplying it to boiler. So at boiler, what happens? Initially, the temperature of the water will increase. So from 4 it will reach a point here. So at this point what happens is the water will change, water will make a change to steam. So at the point 1 the entire water will be changing to steam. So now we have steam in our hand, fully steam, no water, presence of water. So that steam will be supplied to turbine. So at turbine what happens is there will be adiabatic expansion. That's an isentropic process. So here this 1-2 is the adiabatic expansion. So that what will be absorbed by turbine and the entire process will continue. So this is what happens in an ideal theoretical steam turbine. So Rankine cycle is the one which supports this our steam turbine, working of steam turbine, which is represented by our TS diagram, which includes 2 adiabatic processes, then 2 constant pressure process. So this is how we can use Rankine cycle in steam turbine.